far behind today on all of this. My Algebra 1 videos took longer than I expected, and then I had a conference call with Mr. Dobbins, and I'm just kind of running really behind today. I can't even believe it's 2 o'clock. I literally just had a quick bite to have lunch so I can get back into this, and my computer died, so we were charging it up, and it's still only at 48%. Anyway, so we're going to do some operations, so like adding, subtracting, all that. So let me just go over some of this simple stuff. When it's multiplied by a number, just a number itself, it's called a scalar. You should understand that word from geometry. You did scalar stuff back then. If it's negative, just know that it will reverse to the opposite direction. Okay, so there's some pictures. So like you had v and it multiplied by 2, a half, and then it was negative, not the opposite way. When adding, this is kind of the geometric situation that happens. If you have v and w added together, you create v plus w. So the summation of that's called the resultant, and it goes for the tail of v and the tip of w. That's where kind of where things go. Subtracting, so if you have v and negative w, which is basically adding, so that's kind of what's saying right here. This is the resultant of what happens, and it's the same tip to tail situation. Okay, so just to write it out in like math, literally, here's kind of the rules. So scalar multiplication, if you have k times v, you end up with ka and kb, and I'll write the 1 and the 1 here. All right. So that's the 1 to match up right there. So just saying that you're multiplying each part of the component in the vector by that constant. If you're adding v and w, you're just adding a sub 1 and a sub 2, and then b sub 1 and b sub 2. And if you're subtracting, well, then you're subtracting. So a sub 1 minus a sub 2. Remember, order of subtraction does make a difference, so be careful there. Addition order doesn't matter, but subtraction does. So let's just jump right into this. If you have 2c, that means you're going to take 2 times negative 4 and 5, which results in negative 8 and 10. So this is really not that difficult. If you have a and b, that means you have negative 6 and 2, and you're adding that, wow, that looks bad, and 1 and 7 together. So that gives you negative 5 and 9. All right, moving on. I don't know where I'm going to split up this video if I'm going to, so we'll kind of see how things go. And then if you're doing like c minus b, you're doing negative 4, 5 minus 1 and 7, which results in negative 4 minus 1, which is negative 5, and negative 2. Now, some people don't write it that way. I'm just trying to show you it's vector c minus b, and then you can like group it up, but I think you get this goes with this component and this part goes with this part. And then if we kind of do some combination of it, 1/2 a, I think we can figure that right away. If you do 1/2 a, it's going to be negative 3, 1. And again, I'm just showing you the vectors we're subtracting, and then vector b. So if you do that, that results in negative 4 and negative 6. Okay, so let's go ahead and jump into these unit vectors and then kind of go from there of where I'm going to stop this video, probably after this page. So a unit vector is a vector with a magnitude of 1. Okay, so let me highlight this. It's a magnitude of 1, and that is why it's called a unit vector. Kind of like the unit circle had a radius of 1, kind of the same concept. Now, with this rule, I'm going to be throwing you out. Given the non-zero vector v, which means there's no zeros, a unit vector in the same direction of v can be written using the following rule. And that following rule is u equals 1 over the magnitude of v times v. Okay, so we're going to find the unit vectors here, 5 and 6, and go over this, and then we'll stop the video and get second part. Okay, so we need to find the unit vector u with the same direction of the given vector. Okay, so to do that, the first thing I want you to do is find the magnitude. Wow, that looks like a G. Find the magnitude. And if you remember when we do that, you're just squaring and adding and then square rooting. So to do that, you're going to take the square root of negative 5 squared plus 12 squared. Negative 5 squared is 25 plus 144. And if you add that together, you get 169, and the square root of 169 is 13. So if we do this rule, I'm just doing this part. The second part is to do the actual rule. So the 1 over the magnitude times v. Okay, so we have 1 over 13. It's going to be scalar multiplication times negative 5/12. Keep it as improper fractions. So negative 5/13 and 12/13. And that is our answer. Okay, so the next one's not, it's in a different form, and that's okay, and it gives you 2 points. So you're going to do all the same thing. Let's just figure out what the vector form of AB would be first. So in this, we're going to find the vector form of AB. And if you remember to do that, you do 6 minus 0, and then negative 1 minus 7, negative 7, which is adding. So we get the vector of 6 and 6. Okay, so the step 2 would now be the step 1 over here. We're going to find the magnitude. So magnitude of AB, it's going to be 6 squared, so 36 plus 36. 36 plus 36 is 72. And then we have to simplify this. So 72 divided by 2 is 36, and that's actually a perfect square, so I'm just going to stop there. So it ends up being 6 square root of 2. And then the third step, we're actually going to find this unit vector. So we're going to do, and I don't know why I circled it, that's going to bother me. Okay, so we do the 1 over, and in this situation, the magnitude of AB times AB. So we have 1 over 6 square root of 2. Okay, and hopefully you notice that this square root of 2 is on the bottom, so we're going to have to do something with that eventually. And then you have 6 and 6. When you multiply the 6 in, the 6 is going to cancel, so you really have 1 right now. So you end up with this 1 over the square root of 2 and 1 over the square root of 2, but we're not allowed a square root of 2 on the bottom. So if you remember, you multiply the top and bottom by the square root of 2, which gives you square root of 2 over 2. So your final answer is the square root of 2 over 2. All right. So that is unit vectors, so not too difficult. I'm going to go into the standard unit vector a little bit, and then I'm going to stop and go into these notes on the next video to try to break them up a little bit. Okay. So the standard unit vectors I and j are positioned along the x and y axis, and they would be defined as 1, 0, and 0, 1. And hopefully you can see why, because this is I, has a coordinate point of 1, 0. So that distance horizontally is 1 with nothing vertically, and then this only has vertically, so the 1 goes there. Okay, so I'm going to stop the video. I'm going to move on to the next one. It should be coming up in the left-hand corner, so you can click right onto it. All right, see you in the next video.